Dr. Pavitra Bharadwaj. I am Associate Professor in the Department of Computer Science, Jesus and Mary College, University of Delhi. So friends, we are talking about the topic of data mining, and in the last lecture we were talking about the various types of data sets and how the attributes of the data sets they are classified. So we had talked about 4 types of attributes, that is the nominal, the ordinal, the interval and the ratio attributes, and we had understood that the nominal and ordinal attributes are collectively referred to as categorical or qualitative attributes, right, and interval and ratio attributes are called as quantitative or numeric attributes. So we are saying that these are quantitative attributes because they are represented by numbers firstly, and they have most of the properties of numbers. So what are the properties of numbers? Now properties of numbers: addition, subtraction, division, multiplication, right. So the quantitative attributes can be integer valued or they can be continuous, right. The types of attributes can also be described in the form of transformations, that is what we had seen. That is, what are the changes we can make, what are the permissible transformations which can be done to the attribute, so that even if we change the value of the attribute, still the meaning of the attribute will remain preserved. So there are certain statistical operations that will make sense for a particular type of attribute, and those that will yield the same results even when the attribute is transformed by using a transformation that preserves the attribute's meaning. So this type of transformation is very important, because sometimes we will have to change we will have to put some statistical function to the value of the attribute, but that should not affect the meaning of the attribute. So let us see what are the different types of permissible transformations which we can define the different attribute levels. So the first type of attribute that we see are the nominal attributes. So we understand that these are qualitative attributes and they only allow the equal to or not equal to operation of the numbers. That is, they will only tell us that whether the two values are equal or they are not equal. So in this case, when we have a one-to-one mapping, right, so that kind of transformation can be allowed. Like for example, if we have an employee ID, right, so these are numbers and we we reassign the employee IDs, then it will not make any difference. Say for example, initially the employee IDs were E01, E02, and later on the employee IDs have been changed to E001, E002. So what is happening? There is a one-to-one mapping between the old value and the new value. So this transformation is absolutely permissible, and therefore this is going to be allowed, because it is not going to change the meaning of the attribute employee ID. The second type of attribute are the ordinal attribute. So we said that these are allowing us to arrange the data in a particular order, right. So any order preserving change of values will be allowed. Like for example, if we have the old value, we apply some function to the old value and we get a new value, right. Now if f is the function which we are applying, right, so then the new value will be a function of the old value. So in this case, the order is going to be preserved, the order will remain same. Like for example, if we have the rating values of good, better and best, so instead of writing good, better, best, we are writing 1, 2 and 3, right, or we are writing 0.5, 1 and 1.5. So what is happening? The value is definitely going to be replaced by the new value, but still the meaning will remain the same because the ordering is preserved. The third type of attribute are the interval attribute. Now what type of transformations are allowed by the interval attribute? Where we do a multiplication or we do an addition or a subtraction to the old value to get a new value. Like for example, if we have the temperature in Fahrenheit, right, so we can convert the temperature in Celsius and that is not going to make a difference to the meaning of the value of temperature, right. So, the sign of the degree, that is the degree is going to change, the unit is going to change, but the interval is going to remain the same, right. So, the value is, the meaning is preserved. And the third type of transformation which we, the fourth type of transformation which is allowed in the ratio attribute is where, you know, we are converting, we are multiplying or we are dividing the old value to get a new value, right. So, what is happening here in this case, like for example, we are having the data of mass in grams. Now, if you want to convert it into kilogram, you only have to do an addition, division or a multiplication, right. So, what is going to happen here, the meaning is going to preserved even when you are multiplying the old value with a constant number. So, the new value will be a function of the old value, and the function is actually a multiplication or division kind of function, right. So, this type of transformation of the attributes, whatever operations we perform, they should be preserving operations, that is they should remain, the meaning of the attribute should remain preserved, right. Now, if you know, we have looked at the different types of attributes and we have seen what are, you know, the operations which are allowed with these attributes. Now, we also have to see how we can define the attributes by the number of values that they can have, right. So, attributes can have single values or they can have continuous values. So, one type of attribute are known as discrete attribute. Discrete attribute means the values are finite or they are countably infinite set of values, right. So, they are they can be categorical such as zip codes, ID numbers, numeric numbers or counts, right. So, we cannot say, you know, that how many IDs for employees will be needed. As the number of employees will grow on, the number of IDs will also grow on. So, therefore, it is a infinite set of values, or it can also be a finite set of values. Say for example, if we have student IDs, so definitely we know the number of students in an academic year, so that is a finite set of values. So, these are discrete values, a particular value is assigned to them, right. So, these values are generally represented using integer variables. Then we have another type of discrete variable attribute which is known as the binary attribute. Binary attribute is a special case of discrete attribute only, because in binary only two values are allowed. Like two values means it can be a true or false, it can be a yes or no, it can be a 0 or 1 or male or female. This kind of values are allowed, this kind of values can be given, right. So, binary attributes, they are generally, you know, Boolean variables. So, they will take value either 0 or 1. Then we have discrete. Now, we also have another type of attribute called continuous attribute. Now, in discrete attribute, we said that the value is going to be an integer value, but in continuous attribute the value can be a real number, right. For example, temperature or height or weight, where the value can be, say, like for example 168.2 meters or 168.2 centimeters, you know, or the weight can be 12.8 kilogram, like this. So, continuous values are actually floating point variables, and real values can be measured and represented only with limited precision. These values are you know, they have limited precision with which you can do this. Next type of values are the attributes are the asymmetric attribute. Now, asymmetric attributes, they have a very typical, you know, feature, that is we are only you know, interested in the non-zero attribute, right. So, the presence of a non-zero value in the attribute is regarded as important, right. So, when we have binary attribute where, you know, we have only 0 and 1s, so we are only looking at the non-zero values in case of binary, asymmetric binary attributes, right. So, asymmetric attributes could be discrete, they could be continuous. Like for example, if we have the number of credits which are associated with each course we are recording it. Then the resulting data will consist of asymmetric discrete or continuous asymmetric, right. So basically the asymmetric attributes are the non-zero values. Wherever the non-zero values are important, only that. For example, if we have a number of courses which are being offered to the students, right. Say there are 50 courses, out of which the student has to choose 5, right. So for each student data object there will be 5 ones and 45 zeros. So what we are interested in is the ones where the value where the attribute is having a 1, because only those are the courses which the student has picked. The rest of the fields which is 0 values are of no importance to us, right. So that kind of data set in which we are only looking at the ones, we are only looking at the non-zero attribute, that kind of attribute are known as asymmetric attribute, right. Now we have seen that what are the different types of attributes and how the attributes are measured, right. So we also need to have an understanding of certain general important underlying basics about the measurement, right. That is, we understand that distinctness or order or intervals or ratio, they are the only 4 properties of data, but many other properties may also exist in the data. These are not just the 4 operations which can be performed. Like for example, we have cyclical data. Now what is cyclical data? When say we are when the same phenomena is repeating over a period of time. Say for example, rotation of the satellite around the surface of the earth. Now in that case the satellite will be at the same position after a given amount of time. So that is a cyclical data. Then we have data which can be represented in the form of sets or subsets, right. So that kind of data is also going to be there, that kind of attributes are also going to be there, that kind of properties are also going to be there. So for the moment we are looking at these 4 types of properties, but besides this also properties may exist. So this is not this is to be understood, this is not a complete list of properties of data that we are looking at. Then the numbers or symbols which are used to capture attribute value may not capture all the properties of the attribute, or they may suggest the properties that are not there. So we have discussed this earlier also, that for example we have numbers to represent, we have numbers which are representing the ID or the number which is representing the account number, but the account number which is actually representing a number is not inheriting the properties of numbers. It is not going to show you, it is not going to have that kind of properties which other numeric data is going to show. And another very important point is that data will be transformed for the purpose of analysis. We have seen that there are permissible transformations which are done, like for example temperature which is given in Fahrenheit may be converted into Celsius, length which is given in kilometer may be converted into meter. So for the purpose of analysis, transformation of data is very much allowed and only permissible transformations are to be done. So after understanding about the attributes and what are the premises on which this understanding of attribute works, now we are in a position to look at the different types of data sets which are available to us. So there are 3 types of data sets which people will generally work on, or we categorize the data sets into these 3 types. So the first type of data set is the record data set, the second type is known as the graph based data, and the third type of data is known as the ordered data set. So the general, before we actually look at the actual data sets, it's important to also know some general characteristics of the data sets, right, because if you know the general characteristics of the data set, it is easier to understand the characteristics of the individual type of data set, that is record, graph or order data set. So the three characteristics, which will apply to many data sets, right, and they have a lot of impact on the data mining technique which is selected. First is dimensionality, second is distribution, and the third is resolution, right. So dimensionality is, dimension basically is a word which is used for attributes, right. So when we say dimensionality of the database, of the data set, we actually mean the number of attributes that the object in the data set will possess. How many attributes are there, right. So it is very well known that analyzing the data with a small number of dimensions will be qualitatively different from analyzing a moderate or high dimensional data. High dimensional data means that there are too many attributes associated with the data object. So it will be difficult to analyze the data which is high dimensional. Therefore, what is done is dimensionality reduction is performed. So when we are pre-processing the data, we try to reduce the number of attributes. We will remove the number of attributes which are not very significant, which do not have a significant implication on the outcome of the analysis, right. So high dimensional data will have to undergo the dimensionality reduction. This is done to avoid, the curse of dimensionality. This is a term which is often used by data scientists, which is called as the curse of dimensionality, that although we are capturing a lot of information, but eventually that much of information is of limited use. Then next is distribution of the data set. So distribution of a data set is basically the frequency of occurrence of various values or set of values for the attribute comprising the data objects. That is, certain values will keep on repeating for most number of data objects. So the distribution of a data set can be considered as a description of the concentration of objects in various regions of the data space, right. So we understand that in statistics and in mathematics, we have distribution, like we have the normal distribution, the Gaussian distribution, and for each distribution the properties are described. So what we are going to look at is, we are going to look at that how the data values are distributed in the entire data space for a particular data object. So that will follow a particular distribution, and those properties of the distribution can be applied to that particular data set, right. So distribution, like for example, we know that 95% of the time the values will fall in one particular category, right, and only 5% of time will they be outside. So this skewness in the distribution can make the classification very difficult, right. So we have to look at the data, we have to look at the values which are lying in the normal range of distribution, right. Another case of skewed data is sparsity. Sparsity basically, for sparse binary count or continuous data, most attributes of an object will have values of 0. When we were discussing asymmetric data, we found that we are interested in the values which are non-zero. If we have fewer than 1% of non-zero values, then it is known as sparse data. So sparsity is an advantage because the non-zero values will only be stored and manipulated. We are not going to be concerned about the zero value. So the result of sparse data is going to be more significant because it is going to save a lot of computation time and storage, because there is very less amount of non-zero value. Then the third property which is very important for data sets is the resolution of the data set. That is, it is possible to look or to have the data at different levels of resolution, right, and at different resolutions the data will show different property. Like for example, the surface of the earth, if you look at a resolution of few meters, it will look very uneven, right. But if you look at a higher resolution, that is, if you look at the surface of the earth say about tens of kilometers resolution, then it will look relatively smooth. So likewise in data also, if you look at the data, then the patterns in the data will also depend on the level of resolution. If you look at too fine a resolution, then the pattern will not be visible, right, it will be buried in noise, right. And if you look at too coarse resolution, then the pattern will disappear, you will not be able to notice any kind of pattern in the data whatsoever. So therefore, you know, variations in another example of this could be that when we are looking at variations in atmospheric pressure, right, on a scale of hours, right. So it will reflect the movement of storms and other weather systems, but on a scale of month, that phenomena will not be detectable. So resolution means whether you are looking at the data from what distance, or from, you know, distance in terms of time period, distance in term of unit, at what distance you are looking at the data, at what resolution you are looking at the data, that will determine whether you are able to identify the pattern or you are not able to identify the patterns in the data, right. So now we know about the three properties with which, you know, we can understand the different types of data sets, and we had seen that there are three types of data sets, that is the record data, right, we have the graph data and we have the order data. So record data is basically, you know, we understand that the data set is nothing but a collection of records, right. Each object in the data set is actually a record, and each record will consist of a fixed number of fields. Fields are known as attribute, right. So for most basic form of record, we understand data in this form, right. So data can be stored in a relational database, data could be given to us in a flat file, right. So we can have data from any source, but it is important that we understand that the data is in a tabular format, it is in the format of rows and columns. So if we look at this picture, we can see that there can be different variations of record data. So record data could be transaction data, right, it could be a record data, it could be a data matrix, or, you know, it could be a different kind of document term matrix. So different matrices the data can be represented in the form of matrices, data can be represented in the form of tables, data can be represented in the form of a grid of row and column, right. So the first type of record data that we look at is the transaction or market based data. Now transaction data is a special type of record data, because every record, right, each transaction involves a set of items. So what we are looking at in this is, we are looking at, you know, the transaction data where every customer is coming to the grocery store and buying a certain number of items, right. So the transaction 1, 2, 3, 4 and 5 are given, and in each transaction there is some number of items which are purchased. So here it is important that the number of attributes for each record or each transaction or each data object will be different. This is not symmetric, because not all transactions will have all types of objects, right. So individual products are purchased. So this type of data is called as market basket data, because the items are put in the person's market basket, right. So there is it's actually a collection, and it is in no particular order. And attributes are also binary, because we do not know if there are 1000 items in the store, for certain items only the value will be 1 which are purchased, for the items which are not purchased the value will not be there, and it will be discrete, right, depending on the number of items, or it can be continuous if you are looking at the total number of, you know, total amount of purchase. The next type of record data is the data matrix. Now in the data matrix, basically all the data objects in the collection of data have the same fixed set of numeric attribute. Like we saw there, the number of attributes was not fixed. Here in data matrix the attributes are fixed, right. So these are actually a multi-dimensional space, right, and because we are saying it is a matrix, so matrix means that it will have m by n matrix means it will have m number of rows and n number of columns. So this is called a pattern matrix or data matrix, right. So data matrix is basically again a variation because it will have numeric attribute, and it is called matrix because the matrix functions can be applied to this kind of data, right. Then the third type of matrix is the sparse data matrix. In sparse data matrix, again it is a special case of data matrix where the attributes are of the same type and are asymmetric. That is, we are only looking at non-zero values. So transaction data is an example of a sparse data matrix because you will have only 0 and 1 entities, and in this, because you are having zeros for the items which were not purchased, ones for the items which were purchased. So there will be more number of zeros because every customer will only purchase a very limited number of items which are available in the store, right. So in particular, the order of terms in a document, if you look at a document kind of matrix, then that also, if you are looking at the number of times each word is appearing in the matrix, then that term is also it's also showing a vector, and the value of each component is the number of times the corresponding term is occurring in the document. So this example we had seen earlier also when we were looking at statistical techniques. So this was all about the data matrix and the record data. We will be continuing the discussion on the types of data sets in the following lectures. Till then, please keep watching CEC. Thank you.